To determine the appropriate wire and breaker size for an electric range, several steps are involved. These steps include calculating the demand load, identifying the demand factor for the range, calculating the amperage, and selecting the appropriate wire and breaker. The demand load is calculated by multiplying the nameplate rating by the demand factor. The demand factor depends on the total connected load and the type of appliance. For electric ranges, refer to Table 220.55 in the National Electrical Code, or NEC. The demand factor for a freestanding electric range is 8% plus 10% for each additional 2.1 kilowatts above 12 kilowatts. Given a nameplate rating of 14.1 kilowatts, we proceed as follows. Firstly, we identify the amount exceeding 12 kilowatts, which is 14.1 kilowatts minus 12 kilowatts, equaling 2.1 kilowatts. Secondly, since the excess is exactly 2.1 kilowatts, we only add one increment of 10% to the base demand factor of 8%. The total demand factor is therefore 8% plus 10%, resulting in 18%. Thirdly, we calculate the demand load by applying the demand factor to the nameplate rating. This calculation involves multiplying 14.1 kilowatts by 0.18. This gives us a demand load of 2.538 kilowatts. To calculate the amperage, we divide the demand load by the voltage. In this case, we will use 240 volts. So the amperage equals 2.538 kilowatts divided by 240 volts, which is 10.58 amps. It is important to note that you cannot connect a 14.1 kilowatt range to a 120 volt circuit. Based on the calculated amperage of 10.58 amps, a number 10 AWG copper wire and a 15 amp double pole circuit breaker would be suitable for this application. The calculated amperage of 10.58 amps aligns better with intuition than the initial calculation of 58.75 amps. This confirms that using the demand factor of 18% is appropriate for this application. Now let's delve deeper into the NEC table and the rationale behind demand factors. The NEC, specifically Article 220, provides guidelines for calculating branch circuit, feeder, and service loads. These calculations ensure that electrical systems are safely and adequately sized to handle the anticipated loads. Demand factors are crucial because they recognize that not all electrical appliances operate at their maximum rated load simultaneously. This is particularly true for residential applications where various appliances cycle on and off, resulting in a lower overall demand on the electrical system. Table 220.55 specifically addresses the demand factors for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1.75 kilowatts rating. The table provides different columns, each representing different scenarios and the number of appliances. Column C is commonly used for single household ranges. Note 1 of Table 220.55 provides additional guidance for ranges with a nameplate rating greater than 12 kilowatts. It states that for ranges exceeding 12 kilowatts, the maximum demand in column C shall be increased by 5% for each additional kilowatt or major fraction thereof by which the rating exceeds 12 kilowatts. In the example given, the range is rated at 14.1 kilowatts. This exceeds 12 kilowatts by 2.1 kilowatts. According to Note 1, the demand factor should be increased by 5% for each additional kilowatt. Since we have 2.1 kilowatts over 12 kilowatts, we initially calculated only the allowance for anything exceeding the 12 kilowatts for an amount of 2.1 kilowatts. This leads to confusion because the NEC directs that anything over the 12 kilowatt rating shall be increased by 5% for each additional kilowatt or major fraction thereof. Therefore, for ranges between 12 kilowatts and 27 kilowatts, we are directed to column C. However, Note 1 directs that we are to increase by 5% for each additional kilowatt or major fraction thereof that it exceeds 12 kilowatts. So instead, the calculation should be as follows. Firstly, establish the base demand factor from column C for a single range. This is typically 8 kilowatts. Secondly, determine the amount by which the range exceeds 12 kilowatts. In this case, it is 14.1 kilowatts minus 12 kilowatts, which equals 2.1 kilowatts. Thirdly, calculate the increase in the demand factor. According to Note 1, it is 5% for each additional kilowatt or major fraction thereof. Thus, we have 2.1 kilowatts multiplied by 5%, which equals 10.5%. Fourthly, add this increase to the base demand factor. So we have 8 kilowatts plus 10.5%, which equals 8.84 kilowatts. This value represents the adjusted demand load for the range. To calculate the amperage, divide the adjusted demand load by the voltage. This gives us 8,840 watts divided by 240 volts, which equals approximately 36.83 amps. Now let's discuss wire and breaker selection. The wire size must be adequate to carry the calculated load current continuously without overheating. The National Electrical Code provides tables, such as Table 310.16, that specify the allowable ampacities of various conductors based on their size, insulation type, and installation conditions. For example, referring to Table 310.16 for copper conductors with a temperature rating of 75 degrees Celsius, a number 8 AWG copper conductor is typically rated for 40 amps. This would be suitable for a 36.83 amp load. However, it is essential to consider other factors such as ambient temperature corrections, conductor bundling, and voltage drop, which may require a larger conductor size. The circuit breaker protects the circuit from overloads and short circuits. Its purpose is to trip and interrupt the current flow if the current exceeds the breaker's rating. The breaker size should be selected based on the conductor's ampacity, ensuring that it does not exceed the conductor's rating. In this case, a 40 amp breaker would be appropriate for a number 8 AWG copper conductor with an ampacity of 40 amps. It is crucial to coordinate the wire size and breaker size to provide adequate protection and prevent nuisance tripping. In summary, calculating the appropriate wire and breaker size for an electric range requires careful consideration of the nameplate rating, demand factors, conductor ampacity, and overcurrent protection. Consulting the National Electrical Code and following its guidelines ensures a safe and compliant installation. For the initial calculation, using a demand factor of 18% was incorrect. Instead, you must adhere to the instructions found in Note 1 of Table 220.55, which directs that the maximum demand from column C shall be increased by 5% for each kilowatt or major fraction thereof that exceeds 12 kilowatts. Applying this rule, the more precise amperage calculates to 36.83 amps, which would require a number 8 AWG copper wire with an ampacity of 40 amps. This number 8 AWG copper wire would require a 40 amp breaker. Some additional considerations when installing an electric range: you must ensure that the wiring method complies with local electrical codes and regulations. This may include using appropriate conduit cable types and cramming techniques. Additionally, it is important to properly terminate the conductors at the range and the breaker panel, ensuring tight and secure connections. Loose connections can cause overheating and arcing, which can lead to fire hazards. Before starting any electrical work, always disconnect the power supply to the circuit and verify that it is energized using a voltage tester. If you are not comfortable working with electricity, it is recommended to hire a qualified electrician to perform the installation. The electric ranges typically require a dedicated circuit, meaning that no other appliances or devices should be connected to the same circuit. This helps prevent overloading the circuit and ensures that the range receives the necessary power. Additionally, electric ranges should be properly grounded to protect against electrical shock hazards. The grounding conductor should be connected to the grounding electrode system of the building. When selecting an electric range, consider the features and specifications that best suit your needs. This may include factors such as the number of burners, oven capacity, self-cleaning options, and energy efficiency. Energy-efficient ranges can save you money on your electricity bill over the long term. Before installing a new electric range, carefully read the manufacturer's instructions and follow their recommendations for installation and operation. This will help ensure that the range is installed correctly and that it functions safely and efficiently. Regularly inspect the electrical connections and wiring of your electric range to ensure that they are in good condition. Look for signs of damage, such as frayed wires, cracked insulation, or loose connections. If you notice any problems, have them repaired by a qualified electrician. When cleaning your electric range, always disconnect the power supply and allow the range to cool down completely. Use a mild detergent and a damp cloth to clean the surfaces of the range. Avoid using abrasive cleaners or scouring pads, as they can damage the finish. If your electric range is not working properly, consult the troubleshooting section of the owner's manual. This may provide solutions to common problems such as a trip breaker, a faulty heating element, or a malfunctioning control panel. If you are unable to resolve the problem yourself, contact a qualified appliance repair technician. Consider the long-term maintenance requirements of your electric range. This may include periodic cleaning of the oven, replacement of heating elements, and calibration of temperature controls. Regular maintenance can help extend the life of your range and keep it functioning at its best. In addition to the NEC, there may be other applicable codes and standards that govern the installation of electric ranges. These may include local building codes, utility company regulations, and manufacturer specifications. Be sure to comply with all applicable requirements to ensure a safe and compliant installation. When purchasing electrical equipment, look for products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL Semcor. This indicates that the product has been tested and certified to meet safety standards. Ensure that the electrical panel has sufficient capacity to handle the additional load of the electric range. If the panel is already fully loaded, you may need to upgrade it to a larger size. This may involve replacing the panel, adding additional circuits, and upgrading the service entrance conductors. When running new wiring for the electric range, use the appropriate type of cable or conduit for the application. This may include using non-metallic sheath cable, armored cable, or electrical metallic tubing. The wiring method should be selected based on the installation environment and local code requirements. Properly support and secure the wiring to prevent it from becoming damaged or disconnected. Use cable ties, clamps, or other approved methods to support the wiring at regular intervals. Avoid running the wiring in areas where it could be exposed to physical damage or extreme temperatures. Label the circuit breaker for the electric range in the electrical panel. This will make it easier to identify the circuit in the future and will help prevent accidental disconnection of the range. Use a permanent marker or label maker to create a clear and legible label. Document all electrical work performed, including wire sizes, breaker sizes, and grounding connections. This documentation can be helpful for future maintenance or troubleshooting. Keep the documentation in a safe and accessible location. Before making any electrical connections, ensure that the surfaces are clean and free from corrosion. Use a wire brush or emery cloth to clean the conductors before making the connections. Apply an antioxidant compound to the connections to prevent corrosion and ensure good electrical contact. When tightening electrical connections, use a torque wrench to ensure that they are properly tightened. Over-tightening can damage the conductors or terminals, while under-tightening can result in loose connections. Follow the manufacturer's torque specifications for the specific type of connection. After completing the electrical work, inspect the installation to ensure that everything is properly connected and secured. Look for any signs of damage such as loose wires, cracked insulation, or damaged components. Correct any deficiencies before energizing the circuit. Test the operation of the electric range to ensure that it is functioning properly. Check the heating elements, oven controls, and other features to verify that they are working as expected. If you encounter any problems, troubleshoot the issue and correct it before using the range. Educate the occupants of the building about the safe operation of the electric range. Explain the importance of not overloading the circuit, using the correct cookware, and keeping the range clean. Provide them with the manufacturer's instructions and any other relevant information. Periodically inspect the electrical system to identify any potential hazards. Look for signs of wear and tear, such as frayed wires, cracked insulation, or loose connections. Correct any deficiencies promptly to prevent electrical problems. Consider installing arc fault circuit interrupters or FSIs to protect the circuits that serve the electric range. FSIs are designed to detect arc faults, which are a common cause of electrical fires. They can provide an additional layer of protection against electrical hazards. Use surge protection devices to protect the electric range from voltage surges. Voltage surges can damage the electronic components of the range and shorten its lifespan. Surge protection devices can help prevent this damage and prolong the life of the range. Consider having a qualified electrician perform a periodic electrical safety inspection of the building. This inspection can identify any potential hazards and ensure that the electrical system is in good condition. The electrician can also provide recommendations for improving the safety and efficiency of the electrical system. Stay up to date on the latest electrical codes and standards. The electrical codes are constantly evolving to reflect new technologies and best practices. By staying informed, you can ensure that your electrical work is safe, compliant, and up to date. Obtain any necessary permits before starting any electrical work. Many jurisdictions require permits for electrical work to ensure that it is performed safely and in compliance with the electrical codes. Contact your local building department to determine the permit requirements for your project. Use caution when working near overhead power lines. Maintain a safe distance from power lines to avoid electrical shock hazards. If you need to work near power lines, contact the utility company for assistance. Be aware of the potential hazards of working with electricity. Electricity can be dangerous if not handled properly. Take the necessary precautions to protect yourself from electrical shock and other hazards. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Remember that electrical safety is paramount. Always prioritize safety when working with electricity and take the necessary precautions to protect yourself and others from electrical hazards.